Hello students, today's agenda is to compare homework. We'll be learning about imaginary numbers and you will be able to work on 2.11. Today students will be able to simplify complex square roots and use this practice to solve quadratic equations with complex answers. Okay, so let's begin with very simple examples. And so if we have the square root of -4, this is like saying the square root of 4 times the square root of -1. For the square root of 4, we already know that is 2, but the square root of -1 is the imaginary number. So my answer for the square root of -4 is equals to 2i. Okay, that's the answer. What if we just have the square root of -1? Well, that's simply going to be the imaginary number, okay? And your i's can be written as, this is italics, you can put something like this. Some people put just a little I like that. So either way is fine as long as you put the dot to make sure that it shows. What if we have the square root of -8? Well, that's equals to, and it doesn't matter if you put the whole number first or the -1, that's fine. So it's like saying the square root of -1 times the square root of 8. In this case, we already know that this is the imaginary number, but for the 8, we have to simplify it first. And you have done this practice before, so you can ask me which videos you can review if you need to do more practice on simplifying radicals. So 8 is 2 times 4. 4 is 2 times 2. We're going to get a pair and we only send the captain outside. Okay, only one of them. And the lonely ones, when we don't have pairs, that stays inside of the square root. But now, where do I place, this is going to be part of my answer, but where do I place the imaginary number in here? Well, imaginary numbers are always going to be, if we have a whole number and a radical, it's the placement of the imaginary number is going to be in between them. If we only have the radical, then the imaginary is going to be to the left. If we only have a whole number, you have seen that it's on the right, the I, okay? Okay, let me just do a general list of what would happen in different instances. So plus minus usually comes from equations. And so if we have plus minus the square root of -4, this outside is just going to be brought over. Okay, we just keep it. We already know that this becomes the imaginary number. A negative inside becomes an imaginary number. And square root of 4 is a 2. So that will be my answer. What if I have the square root of -4? Well, I don't have anything on the left of the radical, so I don't bring anything over, but just the square root of negative is the imaginary, and the square root of 4 is 2. What if I have negative square root of 4? Some people get confused, it's like, oh, a negative with a radical. That's imaginary. No, this is outside, so you're just going to bring it over. You're just going to copy it and say the square root of 4 is 2. So it's just -2. Okay, so we have to be careful. The negative inside, that's an imaginary. Negative outside, you just bring it over as negative. What if I have plus minus the square root of 4? Well, this is outside, so you're just going to bring it over. And remember, those come from equations. And then the square root of +4 is just 2. And finally, the simplest of them all, the square root of 4 is 2. Okay, so if you all get confused with the signs, it's good to review this part. But let's go on to solving some simple quadratic equations. Okay, what if we have x squared plus 4 equals 0? The first thing that we're going to do is to subtract 4 from both sides. This cancels and you get x squared is equals to 0 minus 4 is negative 4. We take the square root of both sides because we know that squares cancel with square roots. And so x is equals to, whenever you're solving equations and you have that, it's going to be plus minus. The square root of 4 is 2. The square root of negative 1 is imaginary number. So I've been relating these two graphs, even though we're going to focus more on the graphs in the next unit. And I've been telling you that when we're finding the value of x in parabolas, is because we're looking for points that intersect in the x-axis. Okay, in the x-axis. When we have imaginary number, that means that the parabola will not touch the x. So it might be something like this, or it might be something going down but not going through the x-axis. Okay, so that's when we have imaginary number. And who uses imaginary numbers? Well, those working in electricity, electricians will use those to decide what kind of voltage to use or what kind of cables. Okay, what if we have x squared is equals to negative 9? Well, that's even more simple. All you have to do is take the square root of both sides. X is equals to, just the fact that it's an equation, you're going to always put plus minus. The square root of 9 is 3. The square root of negative 1, right? Negative 1 is the imaginary number. Okay. Okay, one more. What if we have x is equals to, let me circle this, x is equals to negative 32. Oh, x squared, sorry. X squared equals negative 32. We take the square root of both sides, and so x is equals to plus minus. This becomes the imaginary number. I'm going to leave space for the whole number in here. But 32 is not a perfect square. So I'm going to have to do that prime factorization so I can simplify it. It's going to be 2 times 16, 2 times 8, 2 times 4. And I know that these are different ways. You can use different ways to get there, but I'm going to do a pairing here and get 1 from that group, and it goes outside. The other one you just cross out. Another group, and 1 from there goes outside. The other one you just cross out. And then I don't have enough to make another pair. That's lonely, so you leave it inside. And 2 times 2 is 4. Square root of 2. 2 times 2 is 4, and you just bring that. The whole number is going to go on the left of the eye, and the square root of 2 goes on the right of the eye. And so this is going to be your answer. So that's it. Now you can do 2.11 and have fun.